Hey everybody, it's now time to have a look at introducing polynomials to you. Now this is one right here. Doesn't this look like fun? Yeah, okay, that's soppy, isn't it? Let's get into it. All right, first up we'll have a look at what a polynomial is. So here's one, 3x to the power of 4 plus 2x to the power of 6 minus 5x to the power of, 4x to the power of 5 plus 37x squared, etc., etc., etc. Okay. You've done quadratics already, so a lot of this might look familiar. Now, the only thing that's missing is something out the front here. Actually, before we go into this, let's have a look at doing some Year 7 English type stuff. Let's fill in the gaps. Okay. A polynomial is a something that contains only something variables. Now, I said something was missing out the front here. Remember what that was? You remember you're used to seeing things with a y equals out the front? So that makes this an expression. So let's put the expression up there. That contains only non-integer, negative, or one variable. Well, there's some negatives in there. There's nons, there's an integer over there. So that leaves one variable. Well, there is only one variable, because there's an x there, there's an x there, there's an x there, there's only x's, aren't there? Or nothing. So it is only one variable. Now remember, technically, there is an x over here as well, just under me here. X to the power of 0 is 1. Remember that? So 2 times 1 is just 2. So that's really 2x to the power of 0. Okay, next line. Each term contains the variable raised to a something, something, something power. Okay, well, let's look at the powers first. That's a 4, that's a 6, that's a 5, that's a 2. That's the same as having a 1 just here. So they're all integers, aren't they? And hang on a second, they're non-negative, aren't they? That's positive, positive, positive integer. Positive index, positive, and 0 is definitely non-negative, isn't it? So that is a non-negative integer. So they're the things you're looking for. All right, let's have a look at a few bits of terminology. The degree of the polynomial is the highest index value. So where's that up here? The highest index value is going to be the 6. So we can say that the degree of this polynomial is 6. The next one we're going to look at is the leading term. Okay, now leading term, it's not just as simple as saying that's the leading term, that's the term out the front. It's actually the term with the highest index value, which of course is, again, the 6. So the leading term is 2x to the power of 6. Now I'm trying to trick you a little bit with this one, because normally when we write things, we write, like when we've done quadratics, you do the squared term first, then you do the x term, and then you do the constant at the end. You see these ones are out of order. You're right, we normally write them in descending index order. So technically, let's bring that down so we can have a look. Technically, this 2x to the power of 6 should be out the front because that's the leading term, followed by that one and followed by that one. So these three terms are all out of order. We can swap them around, but remember you have to take the signs with you. So let's shift the 2x to the power of 6 out the front. This one to the power of 5 goes next. And the power of 4, which has disappeared under there, comes back here. Of course, that's a plus, and we don't need the plus out the front. All right. So that's a basic introduction to polynomials. All they are just expressions with non-negative integer powers of one variable type. Right? Can't have x's and y's, you can only have x's. All right, let's have a look what we can do. What can we do with a polynomial? Well, is that a polynomial for starters? Nope, you're right. That's not a polynomial because it's got the y. It's got x and y, two variables. So instead of writing y, we use this notation. So what we're going to, whoa, hang on, whoa, there it is, it's changed. Change it to p of x. That's how it's pronounced, p of x. So p of x and polynomial of x is this. So same equation, just instead of y, write p of x. Or q of x, or x of x. No, x of x is a bad idea, but you get the idea. F of x is a pretty common one you'll come across soon, the function of x. All right, so what can we do with all this? We can add or subtract polynomials. Now, just a reminder, remember, you can only combine like terms, basic algebra rules. So let's have a look at an example. So if p of x is 2x cubed minus x squared plus 7x plus 4, and q of x is 5x to the 4 minus x squared plus 2x, find p of x plus q of x. So we're going to add these two expressions together, or polynomials together, I should say. They're not expressions anymore because we've got the equal sign. All right, let's have a look. We want to start with our leading term. So when we combine these two things here, what's going to be the leading term? We've got a cube there, we've got a squared, a 1 and a 0. We've got a 4. So that looks like that's going to be the biggest term, the biggest, the leading term, sorry. So let's bring that out the front. Now, what's going to be next? There was a 4, we had a 3 over here. So we'll bring the 3. Now that's a positive 2, 2x to the power of 3. So we'll bring that here. Next up, we've got some squares. We've got a squared there and we've got a squared there. So remember we're adding these. So negative x squared plus negative x squared is minus 2x squared. Now down to the single x's. So we've got a 7x here and a 2x over here. 7x and 2x is, of course, 9x. And finally, the poor old lonely constant down the end comes and gets tacked on the end. Pretty simple, isn't it? You've done this since about year 8, I reckon. Just should bring back memories. Is there anything else we can do with a polynomial? Yes, there is. We can evaluate polynomials. So let's have a look at one. P of x is 2x cubed minus x squared plus 7x plus 4. Now, what evaluating means is simply substituting an x value into our polynomial. So let's evaluate p of 2. So that just means in place of the x, which we have up here, we're going to put a 2. So that'll be 2 times 2 cubed minus 2 squared plus 7 times 2 plus 4, as you can see down here. Now, I'm not going to go through this with you. You know how to work a calculator. So that just goes and becomes 30. Hopefully you can do that in your head anyway. Does that ring a bell? It's just like finding the value when when x equals 2. If you're doing it, if you're graphing, for example, what do? You substitute a value into one variable, you get the other one. Same thing here. All stuff you've done before. So that's evaluating a polynomial. Next one. What else do? We can expand products. So we're multiplying. And yes, you've done this already with quadratics. Let's have a look at one. This looks familiar, doesn't it? We've got a term out the front times the brackets. What do? That's right. We multiply the first with the first, and we get 6x to the power of 4. Then we multiply the outside by the second term. 3x squared times 5x is, of course, 15x cubed. Then we multiply the third, the outside by the third. So 3x squared times negative 6 is negative 18x squared. Done. Let's do a harder one. It's 2 out the front and 3 in the second. But it's the same process. Start with the first one. First one times the first one. 3x to the 5 times 2x squared is 6x to the power of 7. Then we do the first time the second one. 3x to the 5 times 9x is 27x to the power of 6. Third one, see where it's going here? It's all the same thing. 3x to the power of 5 times negative 6. Now remember the negative. So 3 times negative 6 is negative 18. And then you just x to the power of 5. Now we move to the second one. 5 times 2x squared is 10x squared. 5 times 9x is 45x. And 5 times negative 6, of course, is negative 30. Quick double check. Is there anything we can simplify? Do we have any like terms? No, we don't. So that's our answer. One you may have come across, which may look very familiar, something like this. This will give you a cubic. These are all individual polynomials, but they're all multiplying together. Hopefully you remember to do this part first. Do the last two brackets, multiply the last two brackets first. And then you'll see it just all comes out. X times x, let's put the pointer here, x times x is x squared. X times negative 6 is minus 6x. 9 times x, moving over here now, 9 times x is 9x. And 9 times negative 6 is negative 54. Now have a look here. Remember, look for the inside terms. Let's simplify that. Negative 6 plus 9 is positive 3. Now, if you remember, we haven't used this x plus 5. So let's bring it down. Now we do exactly the same thing as we did up here. Start with the x, start with the first one. X times x squared is x cubed. X times 3x is 3x squared. Then x times negative 54 is minus 54x. Move on to the 5. 5 times x squared is plus 5x. 5 times 3x is 15x. 5 times negative 54, I'm going with negative 270. All right. And we finished? Looks pretty good, except, hang on, I can see a couple of things that we need to simplify, don't we? So what can we simplify? Have a look through it, and we've got x squareds there. We've got x's there as well. We're starting off with an x cubed though, so let's bring down the x cubed. There's no other x cubed. Now we can see the x squareds. 3x squared plus 5x squared is 8x squared. Next one, we've got the x's there and x's there. Negative 54 plus 15 is negative 39x. And then we've just got the negative 2 or minus 270 on the end. Wow. Let's see. Good so far? I know I'm going through it pretty quickly, but again, it's all stuff you've done before, all the same process. Let's see. What else can we do? We can divide polynomials. Nah. Let's leave that for another day. That's enough. Good job. Time to go get some practice. If you really do want to get onto dividing polynomials, so there is another video in Marby Maths, which I don't believe in putting links in other videos. So, but if you have a look, subscribe to Marby Maths, you will see division of polynomials as a video, which you can look at your leisure. Otherwise, just go get into remembering how to add, subtract, multiply, substitute with polynomials. Good luck.